Hi all, I'm Lakshmi. I'm a Snowflake data engineer. I'm making this video like to share my knowledge on the Snowflake. 3 years back when I learned Snowflake, I felt Snowflake so interesting and became a fan of Snowflake. Uh, so I thought it will be helpful if I share my knowledge to the people who are aspiring to become Snowflake data engineer. Yeah, this is the video on first session. We will discuss in this session the overview of Snowflake and what is Snowflake, um, what are the advantages of the Snowflake, and why companies are preferring to use the Snowflake. So before we start this session, I would say to learn Snowflake, it is good to have knowledge on ETL, data warehouse, and familiar with the SQL concepts. I'm not saying like you cannot learn Snowflake without having knowledge on this, but having knowledge on those will help you to learn the Snowflake quickly and comfortably. So just before watching this video, just Google it and grab some familiarity with those topics. That yeah. So let's start the first session without any delay. So my first slide is like explaining what is Snowflake. If you search in Google or the Snowflake site, you will find a big definition explaining what is Snowflake. But I would prefer to explain you in layman words. Yeah. So a Snowflake is a software that can act like as a database, semi-ETL tool, and a data warehouse. Yeah, absolutely. A single software can act like a database, semi-ETL tool, and data warehouse. Now you will ask me, there are several other databases in the data world. Why Snowflake is so special to use by the companies? Correct? Yes, absolutely. There are lots of databases in the data world, and I have listed out some of the on-premises databases here. Let me discuss first about the limitations that we have on these on-premises databases, and then we can compare with the Snowflake. Okay. So let's take an example, Oracle database, to discuss about the limitations. Okay. If you want to work on Oracle, the first thing you have to do is it needs to be installed on your laptop or desktop, correct? And if something goes wrong with your laptop or the desktop, you have to request your manager for the new laptop or the desktop. And again, you have to go to the IT team, IT support team to install Oracle on your laptop again and desktop, right? So, and if you are having Oracle software on your own laptop, you cannot work on any other device except your laptop, correct? This is one of the limitation. And the other limitation is for example, ABC company is using Oracle as a database. ABC company has to maintain some physical equipment in their office locations, like computing servers, storage servers, correct? And if they have to improve the capacity, computing capacities or storage capacity as their business is growing and data is uh, increasing drastically, then they have to buy new physical equipments with lots of money, and it's a costly approach, correct? And um it also has to uh, look for if the business is growing and growing, and it has to look for a few more physical equipments in future. Okay, that is one of the limitation. And the people who already worked on the Oracle know this better. So if user 1 is trying to insert the data in the table 1, and user 2 is also trying to insert the data in table 2, as part of loading the data, user 2 face an error like table 1 is logged, since user 1 is already inserting the data and he did not commit it yet, correct? These are the few limitations on the on-premises databases. And now when comparing to the Snowflake is a software that is provided on the cloud, and you need not to install it on your desktops. You can just go to the browser and create a Snowflake account with a username and password, and boom, you can just start using it immediately. It doesn't need any installation, and it doesn't need to maintain any physical servers and storage capacity by the company. Snowflake will take care of everything. And the locking concept, like user one is blocked the table, right? So in Snowflake, even 1,000 users can insert the data into table one at a time. It will not block the table in Snowflake. Concurrency is possible. Concurrency loading is possible in the Snowflake. And uh, the other thing is, uh, if you have to do the ETL process by taking the data from this on premises databases, you have to connect them to your Oracle databases explicitly, correct? But Snowflake on its own can act as a ETL tool, or automated ETL process can be done in the Snowflake. And if company wants to use third party tools to to do the ETL process, Snowflake is providing inbuilt connectors with some of the ETL tools and also reporting tools. So you need not to explicitly connect the Snowflake with these tools. Okay. And um, Snowflake is introduced in 2012 by the AWS cloud service provider. Later, Snowflake also provided by the Microsoft Azure and uh, GCP. Okay, on these three platforms, Snowflake is available. Okay, um, Snowflake is also supported as data lakes and data engineering. The entire ETL process is possible, um, from extracting to reporting tools. Everything is possible in the data engineer, is possible in the Snowflake. And data science technology is also possible in the Snowflake, right? And as I said, it has inbuilt third party tool connectors, so you can just start using it. Now, as I said, Snowflake is a software, but Snowflake is not just a software. It's a cloud software, software as a service provided on the cloud, which can act like all these. Okay, so it means Snowflake is a SaaS, software as a service. To understand SaaS, you should have some knowledge on cloud service models. Okay, let's go to the next slide to discuss on those cloud service models. So, cloud service models means the services provided in the cloud in three layers. First one is IaaS layer, PaaS layer, and SaaS layer. Okay, in the first layer, IaaS, first, what is IaaS? Infrastructure as a service. Okay. In this layer, cloud providers means it can be in AWS Web Services, Azure, or GCP, Google Cloud. These cloud providers will provide the infrastructure as a service. Infrastructure means physical equipments like computing machines, network routers, and storage data centers. These infrastructure will be provided as a service to the companies if they opt for. Okay, example, you are starting an ABC company and you do not have that much budget to buy the physical equipments to main, and you don't have such big office location to maintain that physical equipment, then IaaS is a best suitable service for you. Okay, you can just go to any of the cloud service provider and ask, I want this service, then immediately they'll provide you the service on rental basis. Okay. And what is PaaS? PaaS is platform as a service. So on the infrastructure, you need to install some operating systems, virtual machines, all these uh, before you start work, right? Some platforms where you need to um, install some softwares, you need some platform. So all those platforms are provided as a service by the cloud service providers on rental basis. So if you opt for pass service, then you are also indirectly using IaaS service, and you will be charged for both of these services. Example, GitHub. GitHub is one of the platform as a service deliverable provided. On that, you can write the code using any of the programming language like Python, Java, and you can build good softwares, good apps, correct? You can build softwares on that. So it's a platform provided by the cloud providers. And lastly, Lastly, it's a SaaS, software as a service. That means the softwares which are already built on the past and providing you as a service by the cloud service providers. You need not to build also any application. You can just start using it if you want that software. Okay. So that is a software as a service. Okay. Now, hope I'm clear here explaining all these three layers. Let's see examples of each layer here. So, IaaS layer IaaS services are provided by all these cloud providers like Amazon Web Services, Google Compute Engines, Azure Missions, Rackspace, DigitalOcean, Cisco Metapod. So these are few examples of IaaS deliverables. And next, pass, and these are all few platforms that are provided as a service to the companies like GitHub, as I already discussed. AWS Lambda also, it's like a platform where you can build the code using any of the programming languages, and you can build software on that, correct? And lastly, softwares as a service. These are few examples like WebEx, Zoom, Google Sheets, Google Photos, Picasa, Gmail, Atlassian, which is a website where you can have all the documentation. Your company can have all the related documentation, and it can be shared for the wider audience sharing it. And Asana is a Jira manager where you can build the tasks, manage the tasks over there. Okay, these are few cloud service deliverables. Okay, since cloud providers are providing you like delivering you these services, they are called as cloud service deliverables. Okay, hope I'm clear. And these are few other examples on SaaS, PaaS, IaaS. I just made one more slide for reference. And till now we are talking about what is Snowflake, and it and we discussed about the Snowflake a little bit. But where exactly Snowflake fits into in the ETL process, and what is ETL? Here I'll try to explain the ETL process. Okay. Um, on the left side, you are seeing three databases. It can be heterogeneous databases or homogeneous databases, doesn't matter. So you ETL is nothing but extraction, transformation, and loading. Okay. So as part of extraction, you will extract the raw data from all these three databases and place it in a single location. Okay. And from that location, you will take the data, which raw data, and make some transformations on that data. Means raw data is not a useful information. Sometimes it may contain invalid data and unused data and some extra columns which are not needed, correct? So you need to convert the raw data into an useful information, useful data, correct? That is possible through transformation. Okay, what is transformation? Transformation is nothing but some activities that you are doing on the data, like cleansing. Cleansing is nothing but you are filling up some column values. If they are having empty, you are filling with some default values, or you want to fill with null values, or you want to fill with some like empty strings like this. So as you decide, you want to fill it up, you want to do some cleansing on that. And validation of data, whether this data is really needed, this number of rows is really needed, or these columns are needed or not. So you will do such kind of validation of data in the transformation also. And if you want to create new columns with some default values, or you want to create a new column with by combining already existing columns, okay, and you want to remove some of the columns which are not needed, uh, and you can filter out the data with filter out unused raw data. So all these kind of transformations you can do it. And other important transformations are like joining. You want to combine the two tables into a single table, right? And splitting one table into multiple tables to segregate the data, and you want to sort the data. So all this kind of massaging on the data is called transformation. Yeah, now the transformation is done, and your raw data now it's a processed data, now it's a useful information, and that useful data is loaded into the data warehouse. Okay, this data warehouse now consisting of a process data which is well structured in a well organized manner, and that organized data will be used by the BI reporting developers to generate the visualization charts, visualization reports, and those reports will be used by the company owners, business owners, to take a right decision on their business. Okay, I hope you are clear on this ETL. And in the next slide, we will discuss more about this ETL process. Okay, I have taken Apollo Hospitals as an example here. Yeah, on the left side, you are having four Apollo Hospital branches, and each branch is using a different data format here to save their patients' data. I, either outpatients, inpatients, doctors, nurses, equipments, everything they are maintaining in their files like CSV files, the first branch. And the second branch, it is using a database, OLTP, online transaction processing. Online transaction processing means it's a database where you can store real time uh, data, processing data. Okay, and the third branch is using an application to create appointments, or to maintain outpatient files. All this, they are using some app. We are getting the data from the application. And the fourth branch is using website to maintain their data. Okay, and we are using ETL tools. It can be Informatica, Data Stage, Talent, any of these ETL tools we are using it, and trying to extract the data from all these branches which are in different formats and different database platforms, correct? So you are extracting from multiple databases from different locations and putting it in a single location. The entire data you are putting it in a single location, that is enterprise database platform, EDP. Yeah, now you got all the raw data in a single location, storage location, and you will use this raw data to transform it. You will transform the raw data, and once it is processed, you will load it into the data warehouse. Okay, and if you look at EDP, you are having four tables. After transformations, I have split it into more tables. That is my scenario. Okay, based on some BI analytics scenario or business scenario. Okay, I split it into multiple tables here, and the transformed data I loaded into a data warehouse which is called enterprise data warehouse. Now entire process data, is existing in EDW now. And a data warehouse is a biggest database location, right? And now you want to segregate the data based on the departments. Example, Apollo wants to maintain equipment information in one of the database, in one of the data warehouse, and nurses information in one of the data warehouse, doctors, cardiology department, like this they want to maintain a segregated data in little chunks. So those are called data marts. Data mart is nothing but a small data warehouse which is having department specified data, and those data marts can be used by the BI analytics team. They will fetch the data from these data marts and build the visualization reports. Okay, it's not mandatory to create the marts always. It depends upon the company's scenario if they want to maintain segregated data. But most of the companies they'll maintain data marts to secure their data from each department. Department one cannot see the data from other departments. Okay. Okay. Now this entire process is a OLAP process, means transforming the data and loading it into a data warehouse and doing it into the chunks, small cubes. You are segregating the data into small cubes so that it will be useful for the BI reporting tools. So analytics purpose you are using this data. So that is why it is called as online analytics process, OLEP process. Okay. This is not just once you will do it, right? Every day you will have the data in the Apollo hospitals. Patients join and they'll discharge. Every day the data will be generated in their databases. So it is a continuous process. And every day at the end of the day, it will load the data into the EDP and then transform the data and then load it into the EDW. Some companies they will load the data hourly, and some companies will load the data daily once at the end of the day, and a few companies will load the data monthly. It depends upon company's requirement and scenario. Okay. And if you see on the right side, I mentioned Tableau, Power BI, Looker. These are the reporting tools, different reporting tools, which can be used to generate the reports like histogram, bar graphs, and bar charts, like this. Okay. Hope I made it clear the entire process here: extract, transform, load. And this is one more slide which is showing the ETL process here, the same. So data sources can be anything like OLTP databases, enterprise applications, apps, third party databases, like or data warehouse also. A data warehouse can also be a data source for other data warehouse. Okay. Web apps and any other cloud data platforms, cloud database platforms. And you will you do the ETL process here and load the data into EDW and then chunk the data into data marts, and that data will be used by the reporting tools. And what is data lake here? Let me tell you the difference between data lake and data warehouse. Data lake will not have the processed data. It just loads the data whatever you are getting from the data sources and store it as a raw data, history data. They'll just maintain that for future purpose. Like if they want some 7 years of data, they'll just maintain data here. And the other difference between OLTP and OLAP is OLTP will be able to store only GBs of data, and it can hold the data for only short period, because every time a new data will be generated, right, it will purchase the old data and try to save the new data. It can hold the data only for few days. But OLEP, that is EDW, can hold the data nearly like 1 TB, 1 petabyte. So uh, that much of amount of historical data, EDW and data lakes can store it. Okay. And this is Snowflake ETL pipeline. So that blue area which I am showing is a Snowflake area where it can do ETL processing, and it can maintain as a data warehouse, and you can segregate the data into logical marts. And once the logical data marts are created, Snowflake gives access to these reporting tools to access or fetch the data to generate into a visual charts. Okay. Yeah, but why Snowflake became so popular if there are old ETL traditions and old databases? Why it has become so popular? Because Snowflake has so many features and advantages which are helpful to defeat the traditional ETL processes and the traditional databases. Okay, let's discuss each one of these. Uh, Features. Okay, web UI, this is one of the first benefit out of Snowflake, where any other database do not have. It's a web UI. Actually, in Oracle, what you will do, you will have to do all the things via SQL commands, right? But Snowflake supports a web UI where you can do those things using web UI also. Example, like creating the table, creating a view, creating database, creating schema, all these are supported through the web UI. And you can do lots of things in the web UI. You Snowflake will maintain the history in the web UI, where what are all the commands you have executed from last 14 days. And you can check each query by clicking on query ID, where exactly my query is going wrong, why it is failed, what is the error. And a query profile also you can look at, where exactly my query is taking time, where I have to renovate my query. All these things you can check on the web UI. So that is very beautiful benefit providing by the Snowflake. And performance, coming to the performance, Snowflake, if you compare the Snowflake with any of the traditional databases or cloud databases, okay, it's 10 times faster than any other database. Damn sure, strongly, I can say, like, it is 10 times uh, quickly executes the given query than any other traditional databases. This performance is being achieved by the Snowflake due to multi-clustering approach, multi-compute missions, which we will discuss in the later sessions. Okay, concurrency, as I said before, 1,000 users can load the data into a single table at a time. Okay, this is also possible due to multi-clustering approach in the Snowflake. Okay, and scalability. uh, we discussed it, like a Snowflake takes the headache of increasing the computing missions, increasing the storage capacity. You know, uh, Snowflake will not restrict you if you are using more and more storage capacity in the Snowflake. It will allow you to store as much as data as you want. Okay, it will not restrict you. That is called scalability. And if you need more servers for executing your query even more faster, Snowflake will automatically take care of extending the computing missions. That is called scalability, right? And pay as you go model. Pay as you go model, what is this? um, that means you pay only for what you use. If you are using 10 GB of data, only pay for that. Don't pay for the storage if you are not using it. Okay, and pay only if you are using those computing missions, otherwise don't pay. For example, take a big query, 1,000 lines of query, it is taking 16 minutes of time in the Snowflake. Okay, it's a very big complex query consisting of lots of aggregations, joins, subqueries, and all this. It's taking 16 minutes of time. Then you pay only for those 16 minutes. And your virtual warehouse, that is cluster, will go into the suspended mode, will go into the sleep mode if you are not using that. So you cannot pay for that. Just for having the virtual warehouse in your Snowflake account, uh, Snowflake doesn't charge you. If you use it only, then you pay for it. That means it's a budget oriented software, Snowflake software, which is at one of the reason, like companies are looking at Snowflake. They are attractive to the Snowflake because of this reason. Okay, and unlimited storage, as I said, already discussed, it will not block you, it will not restrict you to storage extra capacity. Snowflake automatically allow you to storage as much data as you want. Okay, and the snow pipes, it's a beautiful concept in the Snowflake. It will using the snow pipes, it will allow you to automate the ETL process in the Snowflake. Okay, extraction, transform, loading, everything. It will allow you to do by using this Snowflake snow pipes. Okay, and data sharing, there is one concept called data share in Snowflake, where you will be able to share a database or a schema or a table to one more Snowflake account if you wish to, with in like you can create a share in the Snowflake and give the access to that other guy who is having another Snowflake account. Okay, and uh, Snowflake will not charge you for giving access to that share. It will not occupy the space. It will not occupy the computing. It will only the Snowflake guy who is using this data share. If he is querying the data, then that guy will be charged, not you. So that is one of the beautiful benefit in the Snowflake. Okay, and decoupled storage and compute. For now, remember that storage servers and compute servers are maintained independently. They are not related to each other. So if you want to increase the storage in the Snowflake, it does automatically without disturbing the computing missions. And if you want to increase the computing missions, it will do it independently. It will not touch the storage servers. So they are interdependent, decoupled. Because of this, if you are using only 500 GB of data, but you want to increase the speed by increasing the computing missions, you need not to add one more storage server for that. Okay, later in later sessions we can discuss in detail when we are discussing about the this architecture. Okay, easy maintenance. So as I said, you can just install the so you can just create an account in the Snowflake by just going into the browser, and you need not to maintain physical servers, storage servers, computing missions. And you can easily create roles, accounts, and users in the web UI. So it's easily maintained. And Snowflake, it will allow you to create multiple roles and multiple users at one go. You can just create it. Okay, and that is called easy maintenance and handles multi data types. Snowflake is Snowflake can handle multiple data formats like CSV, JSON, Avro, Parquet, XML. So all these kind of data formats it can handle by a concept called file format. So it will not restrict you in using like JSON or XML formats. You can use it. And easy backups, you can take easy backups by the cloning concept in the Snowflake. And Snowflake will not charge you for taking backup in the Snowflake. It will not occupy any physical storage in the Snowflake. That is a beautiful concept in the Snowflake. Okay, so you need not to pay for that storage capacity, right? Though you are having backups in Oracle, if you want to take one database as a backup, you are physically occupying that storage, but not in Snowflake. And easy data restore, uh, it's spell mistake here, it's data restore. That means example, like you unknowingly dropped one of the table. What you will do it in the Oracle database, you will go and ask the admin guy, I mistakenly dropped the table, please restore that table, you will ask it, right? But in Snowflake you need not to go to the admin, you can just write undrop table, and that table will pre-exist for re-exist for you on your Snowflake. And unfortunately you modified some column in the table, you can get back the old data like yesterday's. Okay, that is called easy data restore. And highly secure, the data in the Snowflake is highly 100% secure. You know why? The entire data in the Snowflake cannot be seen outside of the Snowflake site. Okay, you can only see the Snowflake data using only SQL queries or the web UI. Okay, and Snowflake is providing one more facility, like it can restrict the IP addresses. For example, if your organization is using a range of IP addresses for their applications, so for their softwares, so Snowflake will take that range, and Snowflake account will open only in those IP addresses, and you cannot open outside of those IP addresses. So it's very secure. And Snowflake is also providing multi-factor authentication. That means along with the username and password, it is allowing multi-factor authentication, where you will get an OTP to your mobile Duo app. After giving that OTP only, you will be able to log in into the Snowflake. But it's an optional, it's not mandatory to have MFA, but it's a facility provided by the Snowflake for the security purposes. And one more biggest advantage in the Snowflake is vivid documentation. So if you go and search in the Google Snowflake documentation, you will find a almanac, like a very big documentation, where any other traditional databases or cloud databases have such kind of documentation. It's really helpful, and you can learn the Snowflake by using that documentation by yourself also. It's really useful documentation. And SQL skill is not a benefit here, but one of the reason why companies are uh, preferring Snowflake. Every company will have employees who are skilled in the SQL, right? Because it's a oldest procedural language, or oldest structured query language. Most of the companies have employees with SQL knowledge and skill, correct? So they are immediately trying to use a Snowflake, because they already have the employees who can understand the Snowflake with these SQL queries. So that is why it is one of the reason why Snowflake becoming popular in the companies. Okay, these are all the advantages of the Snowflake. Okay, and because of these benefits and advantages, security, um, uh, many customers are willing to use a Snowflake. Now I think in 2023, it's in 2023, there are more than 10,000 customers who are using Snowflake. And Snowflake is evolving like anything, and the customers are increasing drastically. So I would say Snowflake is in trend now, and if you learn Snowflake, you can transform your career as a data engineer, and this is the best time to become a Snowflake data engineer. And let's discuss about DB architectures here. If you want to understand Snowflake DB architecture, first of all you need to understand traditional DB architecture. Okay, let's discuss about the traditional one first, and later I'll move into the modern ones. So these are two traditional DB architectures. One is shared disk and shared nothing. Okay, first we'll discuss about the shared nothing. Shared nothing is nothing but every node, every server, that means every server will have its own storage. That means node 1 is solely responsible for the data having in storage 1. Node 2 cannot access storage 1. So node 2 is solely responsible for the storage 2. And what you will be able to achieve on this scalability is easy. So if you want to add one more node, one more server, you can just one more database, but it's costly, right? You have to buy one more computing machine and one more storage. It's a costly approach but easy approach. And there will be no data redundancy. Redundancy means duplicating the data in another database for like if for example, if you have a disaster, like storage one is has a failure. Okay, you don't have any backup data for node 1. So there is no redundancy in this approach. This is one of the disadvantage. And metadata maintenance is problem here, because node 1 is using some tables in storage 1, correct, and node 2 is using some tables in the storage 2. You have to maintain a database like, yeah, this node 1 will use this database, this and these tables. You have to maintain metadata, correct. And data is segregated properly here. You can maintain data securely based on the department wise. And coming to the shared disk, multiple servers are using the same database, same storage. And um, you know um, in this approach, metadata maintenance is easy because it is having a single storage, right? And concurrency is possible here, correct. Multiple servers able to access the same data simultaneously, so that is concurrency is achieved. And here data redundancy is possible. Why? Because uh, they even though they are maintaining a single storage here, they will maintain some extra storage servers where node 1, node 2, node 3 will also be connected to that, having a duplicate data of the storage 1. So if storage 1 is failed for some reason, immediately node 1, node 2, node 3 will shift to that storage 2. So redundancy is possible in this approach. But one of the disadvantages here, as discussed, locks. So if node 1 and node 2 are trying to access or insert the same table, okay, uh, then node 2 will get an error like that table is locked because node 1 is already using it. So there are some advantages and also disadvantages in this approach. Okay, now we are clear with the traditional DB architecture. Then what uh, what architecture is Snowflake is using it? It's using a combination of shared disk and shared nothing. So here virtual warehouses are nothing but nodes here. For now, remember it as a nodes, multiple servers. So multiple servers are able to access the database storage which is lying in a single location, but maintaining different partitions in the single storage location. Understood? So it is using shared disk, like having a single location for storing database storage, and but maintaining data partitions for each of these nodes like in shared nothing. So it is a combination of both these architectures. Okay. And it is like providing advantages from shared disk as well as shared nothing. Okay. So let's discuss about Snowflake architecture here in deep. So there are three layers in the Snowflake. One is cloud storage and computing services layer, which is already called as query processing layer, and cloud services layer. The first layer is cloud storage. Till now we are discussing, as part of ETL process, Snowflake will load we will load the data into the Snowflake and save the data in the Snowflake, right? But to be honest, Snowflake will not store the data physically in Snowflake servers. It doesn't have any specific dedicated databases for Snowflake. It will take the help of cloud service providers for storing the Snowflake data tables. Okay, that means um, it will take when you are creating a Snowflake account, right, it will ask you whether you want to use AWS as a data center, or Azure as a data center, or Google Cloud as a data center. So if you choose AWS as a cloud provider, then Snowflake will store its data in AWS S3 buckets. And if you choose Azure, it stores in Azure blobs. And if you store Google Cloud, it stores in GCP storages. Okay. So the conclusion point here is Snowflakes do not have any dedicated databases to store the data. Okay, and um, second layer is computing services layer, where virtual warehouses will be lying. Those are nothing but physical hardware which are responsible to execute the SQL queries. So, example, one of the user executed a complex query um, in the Snowflake. Then, who exactly is going to execute that query? Who is going to do all those aggregations, joins, um, uh, subqueries, executions? Who will do that? Virtual warehouses will do that. Okay, virtual warehouse will um, execute that query and fetch the data from the cloud storage, that below layer cloud storage, and execute that query, do the aggregations, and the output will be given to the user. Okay, yeah. So virtual warehouse is nothing but a hardware, a server which will have multi clusters. Okay, we will discuss about this when you are discussing on virtual warehouses. Okay, for now remember that virtual warehouses are hardwares who are responsible for executing the queries. And the very first layer, okay, cloud services layer, it's a brain of Snowflake. Everything that goes in the Snowflake, um, uh, like a, it acts like a brain here, the Snowflake. Everything will be taken care in this cloud services layer. Example, like for example, access control. We'll talk about each component here. Access control. So as I said, we once the Snowflake account is created, you need to create roles, right? And you need to give permissions to the users who are using the Snowflake, whether he or she need to access the table or not, that database or not. All this access control will be taken care by this component, creating the roles, creating the users, creating separate accounts. All these will be taken care by the access control. The second one is infrastructure. Infrastructure is a component which takes care of computing machines, that is virtual warehouses. Whether my query, if my query is taking a lot of time and Snowflake wants to increase the virtual warehouses, then who will take care of that, increasing or decreasing the services or our storage capacity? Infrastructure will take care, infrastructure component will take care of that, um, uh, like management. Okay, and transaction management, that means as I said, Snowflake will not block you if you are if multiple users are inserting the data um, into the tables. Some transaction has to be committed, right? If you are updating or inserting DML operations, DDL operations, so that transaction management, loading, everything, committing, everything will be taken care by this transaction management component. Optimizer, it is one of the important component. So optimizer is a component which will check the SQL syntax when you are trying to execute the SQL query. That means if you started executing a SQL query and it has some syntax errors, optimize will take care of that validation. If you have any errors on your Snowflake query, optimizer will throw the errors, it will not process you further. And you made some changes in the SQL query, and now your SQL query do not have any errors. Now optimizer will take that query and ask the virtual warehouse, okay, to execute that query. Then immediately virtual warehouse will execute the query, fetch the data from cloud storage, and give back to the user. So optimizer is responsible in execution of queries, in allowing the user to execution of queries. Security, as I said, I discussed many security approaches available in the Snowflake, right? Like multi-factor authentication and restricting the permissions on the tables. You can grant like and IP addresses whitelisting. All this will be taken care by the security uh, component. And the data in the Snowflake is all encrypted. You cannot see outside of the Snowflake. Only through SQL queries you can see the output. So all those encryptions will be taken care by this security component. And metadata, you all know, data about data. So where exactly the table is lying, in which data partition it is lying, and when the table is loaded, how many columns are existing, what is the count of rows of those tables, everything, all this kind of information will be stored in the metadata. So if you are executing metadata queries like count, minimum, maximum, or table information, show tables, like this, that information will not be fetched from the cloud storage, it will be fetched from the metadata ftb means foundation database, Snowflake foundation database. So it is an internal database in the Snowflake, which is a small database where it will maintain all this metadata related information. Okay, so this is all about Snowflake architecture. I hope I'm clear. We will discuss about each of these components and virtual warehouses in the coming sessions. Okay. uh, Another view of Snowflake here. So as I said, it's a centralized storage, a single location where having multiple database partitions, and the upper layer is multi-cluster computer. So multi nodes can execute executes concurrently. Okay, and the upper layer is nothing but again optimizer, management, transaction, security, metadata, sharing, collaborations, everything. Those layers, the first layer, cloud services layer. Hope I made it clear. Okay. Okay, so as I said, concurrency is possible due to multi-clustering approach, but what is the use of that? For example, in your company you have different projects, you have different departments like finance, data scientist, ETL and data learning, who is ingesting the data, and sales and marketing. So each of these department can use a separate virtual warehouse, so that it will two departments will not be intervened or blocked. Okay, because finance department need not to rely on data scientists, it will have its own hardware, own database to run it. So if you look at here, VWH, those are the virtual warehouses, and different tools can be start using different virtual warehouses for fetching the data from the database partitions. Okay. Okay, and these are all Snowflake partners. I listed out only few here, but there are so many the Snowflake partners which are already having inbuilt connections with these partners. Okay. So if you want to work on Fivetran, you need not to explicitly connect Snowflake with this Fivetran, you can just start using it. And not only Fivetran, there are lots of tools which are already partnered with Snowflake. This is also one of the advantages companies are preferring. For example, if that company is using Fivetran already, so they can just use Snowflake by connecting to the Snowflake. So these are all Snowflake partners. Okay. um, and the skills required to learn Snowflake here, as I said before starting of this session, like it is good to have on some knowledge on SQL and SQL procedures, because Snowflake includes all SQL queries, and for automation purposes we use Snowflake procedures. But I'm not saying like you should mandatorily have this knowledge. When you it's good to have that knowledge to understand the Snowflake commands and Snowflake procedures quickly. Okay, and you should have some decent knowledge on the ETL and data warehouse concepts. Okay, I think we already most of the concepts I have discussed already, ETL and data warehouse concepts, but just go back and grab some knowledge on these concepts. And nowadays Python is widely used with Snowflake, because for automation purposes, for ETL process they are using Python scripts automatically, and to schedule the ETL process, Python script is widely used. And it's a good combination. Snowflake and Python combination is preferred by the companies. Now they are looking for Python developers who are having some knowledge on the Snowflake. Okay. Yeah, that's all on the Snowflake. Thank you so much. Thank you for watching this video. um, like please give me your suggestions or comments, if you have any like opinions on this video. And also kindly like the video, share the video, and subscribe to my channel for further videos. It will encourage and give me a boost to do further videos in YouTube. So yeah, next we will in the next sessions we will discuss a few more concepts on the Snowflake in detail. Okay. And these are the topics I'll be discussing in further sessions, like Snowflake architecture, Snowflake account creation stages, file formats, data loading, data unloading, virtual warehouses, table types, and S3 integration with the Snowflake, cache concepts, view types, time travel, shares, streams, tasks, cloning, snowpipes, micropartitions, UDFs, procedures, roles, and securities. Okay. So I think these are all the topics we will be covering in the further sessions. Yeah. Thank you so much for watching this video again. Please like, share, and subscribe to my channel. Thank you so much. Bye.